My name is Suhaib Al-Atiq. My research was about measuring the speed of the light. I was observing Jupiter's moons that the time of the eclipses of the moon of Jupiter's seems to depend on the relative opposition of Jupiter and Earth. If Earth was close to the Jupiter, the orbit of its moon appeared to speed up. If Earth was far from Jupiter, they seems to slow down, reasoning that the moon's orbital velocity should not be affected by their separation. I deduced that the aberrant change must be due to the extra time for light to travel when Earth was more distant from Jupiter. Using the commonly accepted value for the diameter of the Earth's orbit, I came to the conclusion that light must have traveled at 200,000 kilometers per second. The first serious measurement of the speed of the light occurred in 1676 when I observed that moons of Jupiter and noticed that their eclipses seem to occur at different time, depending on the relative position of Jupiter with the respecting to Earth, being late when Earth was far away and early when Earth was closer to Jupiter. Prediction of the GIM mechanism requiring the existence of charm quark by Sheldon Gioshu, John Leopolis, and Luciano Miani. Many scientists were involved in this project. Galileo adopted that light speed infinity, and then first successful measurement of C was made by Julius Romer. Many other methods were subsequently employed by many physicists to further improve the accuracy of the measurement of C. My rule was to determine the speed of light, which I almost did, and came to the conclusion that light must have traveled to 200,000 kilometers per second. My project has really great impact on physics community because it's helped us to determine speed of light, which is a physical constant that has uses in varying role. From explaining the energy gain for a nuclear reaction with E equal mc to the power of 2 to measure the refraction index of materials. Due to the relative speed, we can even use that knowledge of the speed of light being constant to measure the shift in the frequency of light emitted by object in orbit around the black hole. And from that estimate the mass of the black hole, which due to their properties and invisible, the distortion of light passing nearby are notoriously difficult to measure. As an object approaches the speed of light, its mass raised precipitously. If the object tries to travel 186,000 miles per second, its mass becomes infinity, and so does the energy required to move it. For this reason, no normal object can travel as fast or faster than the speed of the light.